We can see the robot company is booming in China these years. So it's quite a good environment, like people can learn from each other and to pushing the industry development faster.
A new machine just stepped out of the future, and it seems almost alive. China has built a powerful humanoid robot that can walk, think, and work effectively. Although people are excited, they're also a little nervous. Could this robot really start living alongside us like a new species? China's rapid robotics breakthroughs. China has been working very fast to build humanoid robots that can move almost like people do. In the last year or two, these robots have gone from looking a bit stiff and awkward to doing things that many people would not have believed possible. Some of the newest robots can walk, flip, balance, and even perform martial arts moves. These breakthroughs are not just technical showpieces. They show that China is pushing its robotics industry to lead the world in technologies that may change how people work and live. One of the most striking signs of how far China's robots have come is what happened at the 2026 Spring Festival Gala. This event is watched by hundreds of millions of people across China on Lunar New Year's Eve, making it one of the biggest entertainment shows in the world. At this show, humanoid robots from companies like Unitree performed complex sequences of moves, including flips, jumps, and synchronized movements, showing major improvements in robot control, balance, sensors, and software that allows machines to operate together with timing and confidence. Before this year, most humanoid robots could walk in a straight line or stand up without falling. But these newer robots are different. They can do parkour-like moves, leap up and over obstacles, and keep their balance in situations that would make older machines fall over. These skills come from better artificial intelligence systems that help the robot understand its environment and decide how to act step by step. In many ways, these breakthroughs are similar to training a person with practice and feedback. But for robots, it depends on math, data, and precise engineering. China's advances are also reflected in how many robots are now being sold and used. In 2025, Chinese companies were responsible for most of the humanoid robots shipped around the world. Reports show that robots made in China accounted for around 90% of all humanoid robots sold globally, with companies like Unitree and Agibot leading the market. This shows how quickly Chinese companies have improved their machines and made them competitive in price and performance. The rise of China's robotics industry did not happen by accident. There has been major support from the government and many technology firms working together. China's Ministry of Industry and Information Technology has described humanoid robots as a future-changing innovation that could reshape the global economy and the way people live and work. Officials in Beijing see robotics as a strategic industry, similar in importance to electric vehicles or smartphones. These plans push companies to invest in research, train engineers, and build the parts needed for advanced robots. China also hosts large events where researchers, businesses, and investors come together to share new ideas. For example, the Hangzhou International Humanoid Robot and Robot Technology Exhibition brought hundreds of companies from China and abroad together to show the latest in robot hardware, artificial intelligence, sensors, and interaction technologies. Exhibitions like this help spread knowledge, build partnerships, and attract money to the field. They show that robots are not just gadgets, but serious technologies that can be used in factories, in homes, and in services. Another demonstration of how China's robots have changed is in competitions. In 2025, China hosted the World Humanoid Robot Games, where robots from many countries raced, climbed, and completed tasks that tested their coordination and adaptability. One robot from a Chinese company was able to run steadily at speeds similar to a human sprinter, climb steep terrain, and handle difficult obstacles, proving how quickly robot mobility has improved. Events like this push engineers to test their robots in real challenges and inspire new ideas for robot design. One important thing to understand is that China's breakthroughs are not just in one company or one product. They are happening across many companies and fields. Smartphone maker Honor is now entering the humanoid robot market with plans to introduce robots that can move quickly and understand human intentions. These robots may run faster than many earlier models and use new algorithms to respond in real time. This shift shows that robotics may soon reach beyond industrial settings and into everyday life, where people and robots interact closely. The breakthroughs in China's robots today may seem impressive on the surface, but they also point toward future possibilities. Robots that can walk, flip, balance, and coordinate with others represent steps toward machines that could perform more complex roles in factories, in healthcare, and even in homes. These machines may one day help people with tasks that are dangerous, difficult, or simply time-consuming. But right now, the focus is on pushing the limits of what machines can do and showing the world that China is at the center of that effort. And you won't believe what's possible today. The human-machine era. China's humanoid robot makers are now racing to build machines that not only walk or lift things, but also connect with people in a human way. These machines are designed to suggest emotion, understand human presence, and behave in ways that make people feel like they are with a living being rather than a cold machine. The shift away from stiff metal frames toward models with soft, warm surfaces, expressive faces, and eyes that track humans represents a major leap in robot design that is drawing attention around the world. One of the most talked about robots in this area is Moya, developed by Shanghai-based company Droid Up. This robot is built to look and behave more like a person than older robots that simply stood and walked. Robots like Moya use biomimetic design, which means engineers try to copy the way real humans move and interact. Moya's gait or walking pattern is measured to be about 92% similar to a real human's walking style, making her movement feel smoother and more natural than many robots that came before her. What makes Moya different from most robots is not only her movement, but also her physical feel. Instead of cold metal and hard plastic, Moya has soft silicone skin that is designed to feel warmer to the touch. The robot's outer surface is kept at a temperature of roughly 32 degrees Celsius to 36 degrees Celsius, close to human body warmth, which can create an emotional response when people touch or stand near her. This design choice is meant to help people feel more comfortable and less intimidated by a machine standing in front of them. Moya's facial expressions add another layer to this lifelike impression. Her face can perform micro-expressions, such as subtle smiles, nods, eye contact, and shifts in gaze. These small changes in her face make it look like she is reacting to what a person says or does, rather than simply following pre-programmed steps. Cameras inside her eyes help capture the position of people in front of her, and onboard artificial intelligence interprets those cues to make her respond in ways that seem natural. These characteristics are part of what experts call Embodied AI. That means the robot does not just think in an abstract, computer-only world. Instead, its intelligence is linked to its physical presence in the real world, allowing it to sense people around it, interpret their movements, and respond appropriately. Instead of doing only tasks like picking items up or moving items around, embodied AI robots like Moya can interpret human emotions and cues to adjust their behavior in real time. When Moya was unveiled at Zhangjiang Robotics Valley in Shanghai, the event highlighted how China's robotics industry is moving into a new era.
The robot stands about 1.65 meters tall, close to adult human height, and is given proportions similar to a real person. These design decisions are not just for show. By making the robot's shape closer to human, engineers hope that interactions between humans and robots will feel more natural and less like dealing with a tool or device. Not all robots in China focus on full-body interaction. Some models put most of their effort into facial features and emotional expression. At a robotics gala in Shanghai called Agubot Night, a humanoid model named Elf Xuan became famous for its extremely lifelike facial movements. Xuan did things like close its eyes in rhythm with music, tilt its head, and mimic subtle gestures that felt much like a human reacting to sound. This robot did not walk or move much, but its facial expressions were so realistic that many viewers said it was weird to watch. Elf Xuan's body was fixed in place, meaning it did not walk or pick objects up. Still, the robot was an important step in showing how expressive modern humanoids can be. Its capability to blink, glance, tilt its head, and mimic emotional responses shows how robots might one day read human emotions and respond with gestures that feel familiar to people. These expressions come from systems that control dozens of micromotors in the face, making it possible to reproduce many of the subtle movements that humans use in everyday communication. Some robotics engineers believe that such emotional presence is vital if robots are going to work in environments where interaction with humans is constant. This has inspired companies like Headform Technology to make robots with bionic skin and emotion detection systems.
Robots that can read a person's face for emotional signs and then respond in kind could help reduce the discomfort people sometimes feel around machines. These robots aim to make human-robot interaction smoother and more intuitive. There are, however, important challenges and mixed reactions to these lifelike machines. Some people find robots that look very human to be unsettling. This uneasy feeling is known as the uncanny valley, where something that is almost human but not quite fully human triggers discomfort. People have described robots like Moya or Elf Xuan as both fascinating and creepy at the same time. These reactions show that even as the technology improves, people's emotional responses to such robots are complex and not always positive. Experts also point out that while lifelike features are impressive, they raise questions about how humans should interact with machines that appear to understand emotions. A robot that smiles back at you could make a person feel emotionally engaged, even if the robot does not truly feel anything. This can blur the line between a tool and a social being, leading to discussions about how to design robots responsibly, so they help people without causing confusion or discomfort. In addition to facial and movement cues, robots are being designed with customizable appearances. This means companies can create robots that look slightly different, for example, with gendered features or hairstyles, depending on the role they are meant to fill. These customization options aim to make robots more relatable and fit into many settings, from helping children learn to acting as assistants in public spaces. This shift is a major milestone in moving robots from the back of factories into the everyday world of human life. Meanwhile, the statistics are really encouraging. Mass production and market expansion. China's humanoid robot industry is now moving out of laboratories and into real production lines. In the year 2025, Chinese robot makers shipped tens of thousands of humanoid units all over the world, far more than any other country. China is no longer just testing robots. It is building them at a scale that could reshape the global robotics market. In 2025 alone, global deliveries of humanoid robots jumped nearly 480%. Compared with the previous year, with Chinese companies accounting for the vast majority of those shipments. One of the biggest examples of that change is Shanghai-based Agibot Innovation Technology. In 2025, Agibot shipped over 5,100 humanoid robots to customers around the world. That made it the largest single supplier of humanoid robots globally for that year, with roughly 39% of the entire market. Agibot's success is notable because it shows that Chinese companies are not just building robots. They are leading the world in the number of machines they sell and deliver to users. Not far behind Agibot is Unitree Robotics. Their machines are used in many industries, from research and education to commercial shows and pilot programs, making it one of the most visible names in the space. In total, Unitree shipped over 4,000 units in 2025, helping solidify China's dominance in this field. Other companies like UBTech Robotics also made significant contributions by shipping about 1,000 robots, mainly for industrial and commercial use. These results show a real shift in how humanoid robots are made and used. The numbers show a very clear trend. China now produces over 80% of all humanoid robot installations in the world. In 2025 alone, about 16,000 robots were installed globally, meaning they were actually put into service for real tasks, testing, or demonstration. More than 4 out of every 5 of those machines were from Chinese manufacturers. Analysts project that by 2027, installations could exceed 100,000 humanoid robots worldwide, with Chinese firms still holding a major share of that growth. China's success in mass production did not come overnight. It followed years of heavy investment and collaboration among government agencies, universities, suppliers, and private companies. The industrial ecosystem in China supports large production volumes. This system helps robot makers reduce costs and build robots faster than competitors in many Western countries. As a result, China's humanoid robot exports grew not just in number, but also in range, from relatively simple research units to advanced machines used in factories and logistics. One of the reasons behind the huge jump in robot production is that Chinese companies are designing robots for real applications, not just as science projects. The robots are being used for data collection, research, logistics, and early industrial testing. In logistics and warehousing, for example, humanoid robots can help move goods, count items, or perform tasks that are tedious or physically demanding for humans. In manufacturing, they are being tested on complex assembly tasks that require repeated precision. The rapid rise of Chinese production also reflects a broader shift in the robotics supply chain. China now supplies a significant portion of the components used in humanoid robots, from battery systems and electric motors to AI processors and sensors. This local supply makes it easier and faster for companies to build robots without relying heavily on imports. It also means that Chinese companies can develop new models more quickly because they have ready access to parts and technology. Many analysts have said this shift is one reason why China's robot makers can scale up so rapidly. This mass manufacturing has also helped China bring robot prices down in some markets. While cutting-edge models with advanced sensors and capabilities can still be expensive, there are now humanoid robots priced at levels far below what they used to cost. Lower prices make it easier for smaller companies, research teams, and even some industrial clients to purchase and test these machines. This trend puts pressure on competitors in Europe and the United States, where robots often remain costly due to smaller production scales and higher development costs. Another key factor in China's market expansions is strong domestic demand. Chinese manufacturers often find customers within China before they sell overseas. Large companies that are involved in manufacturing, logistics, and data collection are ordering humanoid robots in bulk to explore how they might be used in real work environments. This internal demand gives robot makers a stable base to grow before pushing deeper into global export markets. Chinese firms are not stopping at 2025 numbers. Analysts expect that production volumes will continue to increase year after year. Some industry reports suggest that annual global humanoid robot shipments could reach millions of units by the mid-2030s, with China continuing to produce a large share of those machines. This anticipated growth is driving companies to expand their factories, secure more supply partnerships, and improve their robot designs to meet future demand. However, China is doing more than just creating robots. Robots and the real world. One of the most important steps in making humanoid robots ready for real-world use is training them in realistic environments. In China, engineers are no longer just programming robots on computers or testing them in labs. Instead, they are building large training centers that act like schools or boot camps, where robots learn practical skills that they will need when working in factories, warehouses, homes, or public places. These facilities are now spreading across the country, showing how serious China is about moving humanoid robots from experiments into everyday use. In Shanghai, China opened its first heterogeneous humanoid robot training ground, known as the Humanoid Robot Kailan Training Ground. This facility was designed to house many different kinds of robots, including those built for walking, manipulation, AI reactions, and coordinated motion. In its first stage, the training center was able to work with over 100 robots at the same time, giving them real tasks and collecting data from every action they make. The plan is to scale this to 1,000 robots by 2027, making it one of the most active robot training hubs in the world. At the Shanghai Training Ground, robots are put through specific scenarios that mimic real-life tasks. These include things like sorting objects, moving tools, navigating obstacles, and learning how to operate in industrial spaces. By repeatedly practicing these scenarios, the robots collect large amounts of data, tens of millions of data points, about movement, balance, decision-making, and response to unexpected problems. That data is used to improve the machine's artificial intelligence and controllers so that robots can act more reliably over time. Meanwhile, in Beijing's Shijingshan district, China built what many engineers call the largest humanoid robot training center in the country. This facility spans more than 10,000 square meters and contains more than a dozen different environments that simulate realistic work settings. In one part of the center, robots practice on a mock factory floor. In another, they train in scenarios that look like elderly care homes or hospital environments. Still others resemble home kitchens, living rooms, or retail spaces. The idea behind these training sites is to generate consistent and standardized data that can help robots learn general skills that apply to many places, not just one special lab. Previously, robots were trained indoors under limited conditions, meaning they often failed when taken outside of that specific setup. But now, with these diverse scenarios, robots can practice walking, grasping, lifting, sorting, and understanding environments that are very close to real human spaces. This helps reduce the gap between controlled lab tests and real-world work. One specific center in Beijing has achieved high success in training robots for warehouse and industrial tasks. Robots there use virtual reality and motion capture systems to learn how to carry materials, sort packages, weigh objects, and pack products. In tests, some machines have succeeded in these tasks more than 95% of the time, showing that the training is not just theoretical, but produces real improvements in robot performance. In another part of Beijing, a humanoid robot training base is set up like a data training school. It has full-scale replicas of everyday spaces such as bedrooms, kitchens, and production lines. Robots are trained to do tasks like cooking, sorting parcels, packing materials, placing objects where they belong, and more. Each robot gets personal guidance. In some training programs, 2 human trainers work with one robot to help it learn new tasks step by step. This style of teaching is similar to how humans train workers, but in this case, the robot watches, learns, and repeats actions thousands of times to build functional intelligence. China's training centers are also starting to work with companies building robots, including startups and major technology groups, to collect physical data at scale. As robots train across many different conditions, sensors record millions of motion points, object interactions, balance adjustments, and decision moments. This data is then used by developers to improve robot software, correct errors, and expand the machine's ability to handle new tasks without human intervention. The result of these programs is that China now has humanoid robots that are closer than ever to being deployed in actual work situations. Some robots in these training facilities have already learned to navigate spaces independently, sort materials reliably, and organize objects with high success rates. This suggests that humanoid robots are moving from research curiosities to machines capable of helping people with real jobs in factories, logistics, and service industries. China's emphasis on training and real-world deployment also reflects its broader strategy to accelerate AI and robotics innovation by combining research, education, industry, and government coordination. Training centers act as places where developers can test new algorithms, gather data, and refine robot behavior before deploying machines in everyday settings. By preparing robots thoroughly before they go into real use, China hopes to reduce mistakes, improve safety, and ensure that robots can work productively alongside humans. 1 year ago, training centers were few and small. Today, China has built several large centers in major cities like Shanghai, Beijing, and Chengdu, each with unique scenarios and goals. As humanoid robots continue to improve, future facilities may include even more real-world tasks, from healthcare assistance to construction support, giving robots opportunities to learn even harder skills. These training programs are setting the stage for a future where humanoid robots won't just float around but will be ready to work in the real world.